How do you interpret PV and TS diagrams for multi-stage heat engines? Imagine trying to follow a complex dance where each move affects the next. That's what analyzing PV and TS diagrams for multi-stage heat engines is like. These diagrams are visual maps that show how the engine's working fluid changes during each process. They help us see how energy flows and how efficiently the engine operates. Let's start with the PV diagram, which plots pressure against volume. When you look at a multi-stage heat engine on this diagram, you'll see a closed loop. This loop shows one full cycle of the engine. The shape of the loop tells us what's happening in each part of the cycle. For example, when the engine expands, the volume increases and pressure drops, which shows work being done by the engine. When it compresses, the volume decreases and pressure rises, indicating work input. Isothermal processes, where temperature stays the same, appear as curves that are gentle and smooth. Adiabatic processes, where no heat is exchanged, are steeper curves. By studying these segments, you can tell which parts of the cycle add or reject heat and how much work is produced overall. The area inside the loop is directly related to the net work output of the engine. Now, the TS diagram shows temperature versus entropy. It's like a heat map of the cycle. The area under each process curve on this diagram represents the heat transferred during that process. When you see a vertical line on the TS diagram, it indicates an isentropic process, which is ideal and reversible, like perfect compression or expansion. Horizontal or sloped lines show heat being added or removed at constant or changing entropy. This diagram helps you understand where heat enters or leaves the cycle and how much entropy is generated. It's especially useful for assessing the cycle's thermal efficiency by comparing heat input and output. When analyzing a multi-stage heat engine, look at each process separately. For example, in a gas turbine cycle, the PV diagram shows successive compression and expansion stages, while the TS diagram highlights the heat addition and rejection at each stage. In steam power plants, the PV diagram illustrates how pressure drops and volume increases through each turbine stage, and the TS diagram shows the temperature and entropy changes during steam expansion and reheating. Using these diagrams together gives a complete picture of how the engine works. The PV diagram helps you understand the work done during each process, while the TS diagram reveals the heat transfer and efficiency. By studying both, you can see how each stage contributes to the overall cycle performance. This approach allows engineers to identify where losses happen and how to improve the cycle. It also helps compare real engine cycles with ideal ones, like the Carnot cycle, to see how close the engine gets to maximum efficiency. In summary, interpreting PV and TS diagrams for multi-stage heat engines involves recognizing the shapes and areas of the loops, identifying key processes like isentropic and isothermal, and understanding how pressure, volume, temperature, and entropy change during each stage. This method provides a clear way to analyze and optimize engine performance, making it easier to design better, more efficient engines.